This video discusses the procedure for the Hydrates experiment for general chemistry at Madison College. The objective of this lab is to identify an unknown hydrate by measuring the percent water. You and your partner will want to get a vial of unknown hydrate, and you can see that there'll be a big plastic bin with a bunch of glass vials in it at the front of the room. The unknowns are labeled with two numbers on the top. One number is 134, and that's our course number. The other number that's typed is the number of your unknown, and you'll want to record this number in your lab notebook. So for example, the hydrate that I have here would be, I would record number 36. This is unknown number 36. Of all the vials that you're choosing from, there's only 3 possible unknowns for this lab, or 3 possible identities of your unknown. And I have the chemical formulas of those hydrates here. Remember that a hydrate consists of an ionic compound with a specific number of water molecules trapped inside. A hydrate is a pure substance because it has a definite ratio. So for example, in the case of the first hydrate, for every 1 copper ion, I have 5 water molecules. And that's what the number in front of the H2O represents, is the number of water molecules in each formula unit of the hydrate. To identify your unknown as one of these 3 possibilities, your strategy is to measure the percent water of the hydrate. Each of these unknowns has a different number of water molecules, and it also has a different percent water, mass percent water for the hydrate. Your strategy to find the percent water is that you're going to heat up your unknown hydrate and remove the water and measure the mass that's lost. We're going to assume that any mass that's lost after you heat your hydrate represents the water that was trapped inside. The water will be removed by evaporation when you heat up your hydrate. So this is the strategy that we're going to follow for this lab to find the mass lost. We're going to assume all of the mass lost is water. To heat up your hydrate, you're going to want to do that in an ignition tube. And the ignition tube looks a lot like a test tube, but it has thick glass walls so that it can withstand the high amounts of heat from the Bunsen burner that you're going to use to heat your hydrate. The ignition tube will be in a rack at the front of the lab room. It's not something that you can find in the drawers. So you want to get an ignition tube, and the first piece of data that you need is the mass of the empty ignition tube without anything in it. To get the mass of your empty ignition tube, it's kind of awkward if you just put it directly on the balance because it can roll off. So you can see in my picture here, I've got a glass jar, and the purpose of the glass jar is just to hold the ignition tube. What I did is I put the glass jar on the balance and I pressed tare so that it read 0. Then I put the ignition tube into the jar to find the mass of the empty ignition tube alone. And I found that mass is 57.99 grams, and that's something that you'll want to record in your lab notebook. The next thing that you need to do is you need to find the mass of the ignition tube and your hydrate. For this lab, we want you to measure your hydrate directly into the ignition tube. The reason for that is that the main piece of data that you're getting from this experiment is mass data. You want your mass to be extremely accurate. If you measure your hydrate in a plastic weigh boat and then pour it into the ignition tube, it's a less accurate way of finding the mass because inevitably some of that hydrate might be left behind in the weigh boat. So we want you to measure the hydrate directly into the ignition tube. So what you'll want to do is scoop it into the ignition tube, and you want to get approximately 2 grams of hydrate. So the next piece of data that you're getting is a combined mass. It's going to be the mass of the ignition tube and the hydrate together. Keep adding hydrate until you approximately have 2 grams in the tube. In this example, I'm going to find the amount of hydrate that I have by subtracting these two pieces of data, so finding the difference in mass. So what I'm going to do here is that in order to find the mass of my hydrate, I'm going to take the combined mass, the mass of my ignition tube and hydrate, and subtract from that the mass of my empty ignition tube. And you can see in this example I have 1.81 grams of hydrate at the beginning of the experiment. So I want to record all of this data in my lab notebook. Once you have that mass, you're ready to start heating your hydrate. And this is the setup we're going to use for heating the hydrate. The black stand that's holding your ignition tube is called a ring stand, and you'll find that in the cabinet underneath the sink in lab. The clamp is going to be in a plastic bin at the front of the lab room, and the clamp has a fire-resistant cloth that helps grip the ignition tube. So that's what you'll be using to hold your ignition tube. There's a couple things I want you to notice about this setup. So one thing I want you to notice is, see how the ignition tube is slanted? It's not completely vertical up and down. The reason why you want to slant your ignition tube is that it helps spread out the hydrate at the bottom of the tube, and that'll help you heat it more evenly so that you can effectively drive off all of the water that's trapped inside. The other thing that I want you to notice is, see how the Bunsen burner flame is wrapped around the end of the ignition tube? That's okay. That's something that you probably want when you're heating your hydrate. It's okay to wrap the flame of the Bunsen burner around the tube, or you can think of it as sticking the ignition tube inside the Bunsen burner flame. And this will help you effectively heat your hydrate and drive off all of the water. Now, if you've never used a Bunsen burner before, or if you're nervous about using a Bunsen burner, your instructor is going to show you how to set this up at the beginning of lab, and they'll help you with lighting your Bunsen burner and adjusting the gas and the air so that you have an appropriate size flame. The lab asks you to heat your hydrate for about 5 to 10 minutes, and I would actually suggest that you do plan to heat it for about 10 minutes. As you're heating your hydrate, you might start to notice condensation at the top of your ignition tube, like you can see in this picture here. It's important that you drive off all of the water out of the tube, even condensation that might be present at the top of the tube. If you start to see condensation at the top of the tube, you need to redirect your Bunsen burner flame and position it at that condensation at the top of the tube. You'll want to sweep the Bunsen burner flame up and down the tube as you're heating it until you don't see any condensation left in the tube. And that will ensure that you effectively drove off all of the water that was present in your hydrate out of the ignition tube. When you're all finished heating your hydrate, you're going to need to wait for it to cool down before you can find the final mass. You'll probably have to wait about 10 minutes before you can find the mass. You'll want to make sure the ignition tube is cooled to the touch before you get your final mass measurement. To get the final mass after heating, you're going to want to use the same glass jar like you did before, and you're going to put the ignition tube in there and get that final mass. What you should find is that the mass after heating decreases because you removed the water due to evaporation. The main piece of data that you want for this lab is, we want to know how much water was in your hydrate and how much water was lost when you heated it. To get this piece of data and to find the amount of water that's in your hydrate, you're going to do another calculation. And to find the mass of water lost, you're going to take the mass of the ignition tube and the hydrate before heating it, and from that you're going to subtract the mass of the ignition tube and your anhydrous salt after heating. The anhydrous salt is what you're left with after you remove all of the water from the hydrate. So this is the piece of data, this is the last piece of data that you need in order to identify your unknown. Once you find the mass of water lost, you can figure out the percent water that's in your hydrate, and you're going to match it up with one of those three possibilities for your unknown. When you're all done recording your data and when you finish the procedure for the lab, you can wash your ignition tube in the sink and wash down your anhydrous salt in the sink. The vial of your unknown, the glass vial that was holding your unknown, you want to put it in this plastic container in the front of the room that's labeled used unknowns. It might still have hydrate left in it, and that's okay. Just be sure that you don't mix it up with the unknowns in the original container, the ones that haven't been used. This is the end of your procedure, and I hope this video helps you prepare for lab.